Hi guys, today I wanted to talk you about AC to DC converters, passive, which are very useful in electronics because in a lot of projects, especially with motor, you are going to use them. So let's just simulate the easiest AC to DC converter, which is the Gralz bridge. Let's just put a sine wave with 330 volts of amplitude and 50 Hz as a frequency. Now, because I want to complicate the simulation, let's just put even a transformer. In most projects you are gonna have also transformer coupled with DSC. So let's put it. And let's couple these two capacitance with K, L1, L2 equal to 1. I've explained it already in other videos, but this is just the mutual inductance coefficient, so this is not the turn ratio. The turn ratio is decided between the value of the inductances, and it is given by this equation here. A1 over L2 equal to N1 over N2 square. I will just put like this as a comment, as a reminder. And let's just put here a load, and before running the simulation, let's see that everything is still working. So let's run this for 20 milliseconds. On this side I have this, and this side I have this. Okay, that's quite fine. Now let's add a big capacitance here, and of course a Gralz bridge. I prefer to design the Gralz bridge with Schottky diodes because they are faster and they perform better. The minus is connected to the load and the other part is connected here. Whoa. I just need a little bit more space. And connect them like this. And yeah, it should be fine. We should increase the transient a bit. Okay, as you can see, 10 millifarads are not enough for high voltages, so we should increase the output capacitance even a little bit. Now, of course, you have to design the system properly, but the concept is you are going to... Let's just put 1 second. Okay, you can see the ripple clearly, and yeah, that's it. Basically, this is the most basic AC/DC converter. Generally speaking, the capacitance required is way lower than this, but I don't know for what. I don't know why. Maybe because the voltage is high and the frequency is lower. Don't know. But anyway, you can tune the capacitance, the output capacitance to adjust the output ripple. So now let's suppose that you have a brushless DC motor, and you want to use this brushless DC motor as a generator, meaning that you have physically the motor, and I don't know, with some kind of device, maybe there is a gear, there is something, you are rotating with your own hands with something, and you are generating voltage here. So you're giving torque, mechanical torque at the input with rate of speed omega, and you have a three-phase voltage as an output. So we want to model the brushless DC motor in the easiest way possible without spending so much time. So just put a sine wave with 1 kHz frequency. I don't care. It is of course even less. 20 volts and 0 as phase degree. Then you need, since this is a three-phase system, inductance and resistor. So 10 milliohm as inductance, 10 milliamp as inductance, and 1 ohm as resistor. 0.5 as resistor. Now for the other three phases, just put something like this, and with the only difference that the three other phases are 120 degree in lag with each other. So before going on, let's see effectively that this is a three-phase system, and yes, the answer it is a three-phase system. Now what is going to happen with the full bridge rectifier is that we want basically only to keep the higher portion of your voltage, which is this. So what your full bridge is going to do is to clamp something like this. So let's put the full bridge rectifier, which is in a very, very similar configuration to the Gralz bridge. Here we have the Schottky diode repeated 6 times. The output of these Schottky diodes is grounded again with a very big capacitor, and let's drain 1 ohm or something like that as a load. Let's just put 10, and the anode of these diodes is grounded. I don't know why there is no node. Here there is not a node. So and now let's connect these diodes properly. So let's recap. You have a DC brushless motor, and basically you have 3 wires coming from your motor. Where you should connect these 3 wires? Basically between the diodes. So here. Okay, and basically that's it. This is the output voltage, and if I made everything correctly, it should be fine. Let's run the simulation for 2 milliseconds. Okay, these are not the voltages that we need, don't worry. So this is our 3-phase system, and this is the output voltage. Yeah! So we succeeded in converting our 3-phase voltage in a DC system. As you can see, a bit lower than expected, but still good. So as you can see, this voltage here is will not be stable, either because your constant either because your input torque is not constant, or either because you're not rotating it properly. So what you're going to do, if you wanted to use this system to recharge your phone or whatever, you should connect you should connect this output here. So before putting a load, you should connect this output here with I'm not going to do that in this video, but you should search or made by yourself, DC-DC converter or a linear regulator. So that the output voltage is basically stabilized. Now I will open a real project, which I made for myself. Sorry, don't know why this is empty. So this is the full bridge rectifier that I made with the project. As you can see, in the first part is basically the same of which I showed you. There are just a bit less of capacitance, and as I suggested before, there is a DC-DC regulator. In this case, it is a step up, and what it's gonna do is to boost the output voltage to 3.3 volts, so that you can use this voltage to, I don't know, do whatever you need. And then I put a low side shunt here in the output with a filter, so that I can read the output current whenever I want. Now you can also put a controller here, but basically the output voltage is basically controlled by the feedback pin of this linear technology boost. Let's run the circuit just to show you. As you can see, the input voltage, as you can see, it is not constant. So even though there are some big capacitors here, it is not constant. So you will need a regulator in any case. The simulation is quite long, so I will not run all the simulation, but just a little bit. Yeah, it is very slow, very slow. I can assume that it is slow because the integrated circuit takes time to simulate. Let's just stop it right there. So this is the inductor current of the boost converter, and when as an input you have 2.2 volts, as the output you have 3.5 volts. So as you can see, the boost is operating properly, and it is stabilizing the current, the voltage, and also the current. So I have 50 milliamperes as 50 milliamps as current, and if I choose even a better boost, for instance 5 volts, I can even use this project to recharge the phone, recharge basically every device that you want. And if you study also the K voltage, it is exactly the current that I'm going to read. So as you can see, this is a very beautiful project to do, and it is not even so expensive, since you need just a brushless DC motor and 6 diodes. Thank you for your attention.